Welcome to the third lecture of our series where we are talking about the patterns of distributed system book. So in the book, I think we are in the part of like narratives part, which is very first part of this book. Inside that, we were learning about the promise and perils of distributed systems. In the previous lecture, we understood why we needed the distributed system at the very first glance. So why the single server cannot handle multiple like many requests, that we understood in the last lecture. Now in this lecture we will understand why we should separate the business logic and data layer, why it is helpful, and what are the common approach that we can take to divide our one application into multiple different services. So a very common approach is to separate an architecture into two parts. Is the first part is to move all the stateless component responsible for exposing the functionality to the end user into one side, and the second, which is like a stateful component which is managed by the database, into other. So first we need to understand what is the stateful and stateless. So we can understand it by an analogy. Let's suppose you are going into a restaurant and you have ordered some food. Now the waiter will come and ask for your preference on the food, and based on that he will go and then come up with the food and deliver it to you, and you can have a good lunch or dinner, whatever. Then in the next time when you will go, that same, if you talk to the same like waiter, he will have the proper understanding what all like items, or if you're a regular customer, he will have the idea what all preferences do you have. So in this case, let's suppose after some day if you go back again and that waiter has left the company, then like all your preference and all your data that you have been sharing with that particular waiter has been now lost. So this is the problem with the stateful behavior, where everything is given to one person who has all the access and who has all the details about that particular thing. So to fix that, now you might have seen in many restaurant people use multiple tabs. Each of the waiter will have one tab where whenever you'll go and ask something or order something, they will write all your orders into the tab, and based on your preference, when you go back again next time, doesn't matter if the same waiter is coming to serve you or the different, they will have the tab and they can always search your name and find out all the preferences that you have. So now even though somebody else like who is sitting behind the scene, if he also has the tab, he can also check your preferences and all those things, and based on that he might suggest some food or something like that. So for example, in this case you might understood, right, how the stateless things are very helpful. So whenever you design a system, we try to keep things as stateless as possible, but it's not always going to be helpful. But in most of the scenarios, stateless components are always helpful because you are keeping things apart and not combining two or more things into one, so that you can always reuse that thing for multiple purposes. So let's read this again. The first part is the stateless component responsible for exposing the functionality of end user. This can take the form of a web application or commonly a web API that serves user-facing application. So API is nothing but an application programming interface. It provides you an interface for the application developers to expose their API or reuse their other API to do certain actions, so that kind of you can say like these API are some list of code, some piece of code which runs whenever you call them. So you don't have to rewrite them again and again. It's already written. Now you can reuse them from multiple different server, multiple different if the API is exported publicly, you can also use it from other machines. So that is very helpful. So that's why we are saying we can distribute our all the functionality and all the application logic through an API and use it inside the other like other services if we are using multiple servers. So separating the compute and data. So user requests something, it goes into the app logic. Then app logic exposes an API through network, and then it goes into the database, and database gives the data of that user. So this is how it works. So this way, most of the application logic executes on a separate servers, utilizing a separate network, separate CPU, memory, and disk. This architecture works particularly well if the users can be served from caches. For example, in this case, let's suppose you have already figured out the user preference. What are the user preferences we have? And if the user asks again, hey, can you like order something else? Then you will not need to ask it again, since you already have the user preferences fetched from the database inside the app logic. You can like catch it and then reuse it multiple time, as many time as you want. So that is what we are saying here. uh, like the distributed this architecture work particularly well if the most users can be served from caches put at a different layer in the architecture. It makes sure that only portion of all requests need to reach the database layers. So some portions which are really not available in the cache should reach the database. But as the number of users increases, more servers can be added to handle the stateless business logic. For example, we have now multiple users, so we can always have one app logic or multiple app logic to handle them, because most of the time you will not be calling to the database. So database call happen just once, and more frequent calls if are happening, then you can reuse them through the cache layer that we have in the server or in some other layer. So for example, in this case, we can always scale up this server, like we can have multiple server for app logic and can have just one server for database. So as the number of users increases, more servers can be added to handle the stateless business logic. This scalability allows the system to accommodate a growing user base and ensures that the request can be processed efficiently. In the event of server failure, a new server can be introduced. So in case something goes wrong, we can always introduce a new server. You don't need to replace the whole, you know, whole server which has the database or which has the app logic. If app logic server is failing, we can just replace the app logic server, and database server can always be there. Okay. So yeah, this helps scalability allows the system to accommodate growing user base. Also, like in case some failure, we can introduce a new server and workloads and continue serving the user request seamlessly without like affecting a lot of other services. So yeah, same thing, we have multiple servers for app logic, just one server for database logic. This approach is effective for many applications. However, they came to a point when the amount of data stored in the stateful database grows to hundreds of terabyte. That's true, right? We will come up in some time, we'll have like billions of users and then billions of data. We can't just have one database then in that case. The number of requests to the database layer increases significantly because like there can multiple unique users, right? As the results, the simplistic architecture described above runs into limitations stemming from the physical constraint of our four fundamental resources on the server responsible for managing the data. So the constraint that we talked about earlier, like for CPU, network bandwidth, disk, and memory, can cause some issues that we have to figure out. So to fix that, we have another concept called partitioning of the data. We'll go through that now. When a software system runs into hardware physical limits, the best approach to ensure proper request processing is to divide the data and process it on multiple servers. This enables the utilization of separate CPUs, networks, memory, and disk to handle requests on smaller data portions, right? So for example, now we have also converted our database into multiple different servers. This is like a compute cluster, this is like a data cluster. Clusters are nothing but set of some servers that we can uh, put it into one thing. So scaling data by distributing on multiple servers. So for example, this one needs like two kind of data, which is like multiple tables it needs. Let's suppose one table is fetched from this and one table is fetched from this. We can always do that. Now we have to look at the failures. So there are a couple of failures that we have to, so as the complexity grows, the failure rates also grows, and there are different problems that we might face. We'll talk about failure and how we can fix those failure in the later lecture. For now, that's all.